Chapter 7, the cost of production. This chapter is important because we will bring in long-run cost, which we only covered, partly in the first year. But the first part of the chapter deals with the various costs that we have in production, and then we will deal with just briefly with costs in the short run. But the main focus in the chapter in terms of the semester test will be costs in the long run, and then we will look at why we say long run cost is, or long run to produce in the long run is cheaper than in the short run. And then we will have also terms like economies of scale, diseconomies of scale, and a new term, economies of scope. So I'm just going to work through the slides and then indicate to you what is the important points that you need to cover in terms of the semester test. So basically the first part is just, what cost is there in production, and we know this from the first year. Economists talk about economic cost, and when economists talk about economic cost, they refer to opportunity cost. So just take note of that, what opportunity cost is, the cost associated with opportunities foregone when a firm's resources are not put to their best alternative use. So just take note of this information from last year, but I won't test you again on it. Then also a term that we encountered last year is sunk cost, basically a cost that has been made, but it cannot be recovered. So just take note of that. The rest you can ignore. What is important about the sunk cost, it cannot be recovered. So when a firm makes decisions about production or the future production, it should not influence a firm's decision. Okay, so this is just some information and some practical examples. Then the type of cost from last year as well. Total cost of production consists of fixed costs and variable cost. That is the main. And then the firm shutdown decision also from last year. The firm will only shut down if if the average variable cost is not being covered. So I won't test you again on that. And then some calculations that we have done last year. So I won't test you again on this calculations. This is the calculated short run cost of a firm, and we're looking at total cost, which considers of variable cost and fixed cost, and then we've also got marginal cost, and then average fixed cost, average variable cost, and your ATC. Now the ATC is important in terms of the average cost per unit of a product. So you can work through this on your own, but I won't test you it, in the semester test. Then marginal cost, we know it's the cost resulting from producing one extra unit of output, we know that. And then the ATC, firm's total cost divided by its level of output, average fixed cost, firm's total fixed cost divided by the level of output, and AVC, the total variable cost divided by the level of output. So actually in the short run, the law of diminishing marginal returns is applicable. It means that the marginal product of labor declines as the quantity of labor employed increases. So that is important in terms of the short run. We have the law of diminishing marginal returns. So as you employ more labor to produce more, the marginal product of that additional labor is declining, while the marginal cost will increase as output increases. So maybe the point that you need to take note of, what is the relationship between diminishing marginal returns and marginal cost? But I won't test you again. Then just in terms of short-run cost curves, it just shows you, that the total cost curve consists of the fixed cost, is a vertical sum of fixed cost and variable cost. The fixed cost is the horizontal line, and then the variable cost, in total it gives you TC, that is the total cost. And then the marginal cost, we've got only one marginal cost curve, which is U-shape. And then we've got the ATC, the average total cost, and the average variable cost curve, which is also U-shape. Actually, the ATC and the AVC is derived from your total or average product and your marginal product. All of these curves then gives rise to the average cost curves because of the law of diminishing marginal returns. And then an important point is that the marginal cost curves crosses the AVC and the ATC at their minimum points. But this is first year work. I'm just revising it for the purpose of revision. And then, basically that is short run cost. Now the focus is on the long run cost in the long run. And then what is important is that the aim of the firm is to minimize cost. When we look at the previous chapters, when we look at the theory of consumer choices, the aim of the consumer is to maximize total utility. Now, the aim of the firm is to minimize cost, and in the end, the firm wants to maximize profit. Now, the question is, we need to look at what input combinations of labor and capital. Remember, we assume there are only two inputs, labor and capital, and in the long run, both are variable. Remember, in the short run, we assume that capital are fixed and labor is a variable input. But now we're talking about the long run. So remember from chapter 6, we dealt with the isoquant, which corresponds to what we call the indifference curve. And now a new thing that we will bring into determining the possible or the combinations of labor and capital where the firm will minimize cost, we bring in what we call an isocost line. Now the isocost line corresponds with the budget constraint or the budget line when we dealt with consumer theory. So then we will then combine in one diagram the isocost line and the isoquant to determine what combinations of labor and capital will minimize cost. And so what is an isocost line? It's a graph showing all possible combinations of labor and capital that can be purchased for a given output. Now, you don't need to look at basically, if you look at the isocost line, to derive the slope of the isocost line, basically the total cost of production or total output maybe that you will produce is the sum of the firm's labor cost, W is labor, and the amount of labor that you employ, W is the wage rate, and the capital cost, R, the small r, is the rental rate of capital, what is the cost of capital, and K is the amount of capital that you then employ. So that is a total cost of producing a certain level of output. So when we look at the isocost line, maybe what is important here is that as an equation, it's in a straight line, then K is equal to that equation, but that is not so important, is that the slope of the isocost line is equal to the ratio of the wage rate to the rental cost of capital. So that means W over, minus W divided by R, which the slope is negative. So it's a ratio between how you substitute capital for labor, the change in capital for the change in labor. You employ more additional labor to produce a better output. So just take note, because when we looked at indifference curves and budget constraints, where the consumer is in equilibrium or maximizing total utility, the slope of the indifference curve, which is equal to the margin rate of substitution, is equal to the slope of the budget line, which is a ratio of the two relative prices of the two goods. Now we can also, it corresponds to when we talk about cost of production and identifying the inputs of labor and capital that will minimize cost, we need to look at the isocost line slope, which is the ratio of the wage rate to the rental cost of capital. Now, what is important from all of this is why we bring in the isocost line. And you will see the isocost line is a straight line. There are three isocost lines here, C0, C1, and C2. And then we've got isoquant Q1. Now, what is the aim of this figure is to determine, the firm needs to determine, to produce a certain level of output, in this case Q1, which lies on this isoquant. What will be the combination of labor and capital that will minimize, this output, this given output of Q1? Now, if you look at this diagram, it looks similar to consumer equilibrium where you had the budget constraint, the budget line, which is a straight line, and then you have the indifference curve. And where the highest indifference curve is tangent. Tangent means studs. The budget constraint, that combination of the two goods will give the consumer equilibrium. Now it's the same as in the case of a firm. If you look at this isocost C1, the firm will not choose seed 0 because no combination is possible there. And then if you look at C2, for example, why will the firm not be on that isocost line? C2, you can produce Q1 at C2, but then you have to employ either K2 labor and K2 capital and L2 labor. But that is more expensive. It will yield the same output, Q1, but at a higher cost. Or you can choose combination K3 and L3, but that is also at a higher cost. Okay, so the combination that will, that will minimize cost will be at point A, where the isocost or the isoquant is tangent, or the isocost C1 is tangent to the isoquant Q1, and that gives you a point A. Now, what is then the combination of labor and capital that will minimize cost? In this example, it will be K1, that is on the vertical axis, K1 capital, and L1 labor. So that combination of K1 capital and L1 labor will be the combination of the two inputs that will minimize cost. And that is important for firms from a production point of view because they need to minimize cost and in the end to maximize profit. So this diagram is quite important to show you what combination firms must choose to produce the output, the given output at the minimum cost. Okay, this diagram is not critical for the semester test, and you can ignore this. Right now, when we go further, cost minimization with varying output levels. What we have determined in the previous diagram, what combinations the firm must choose to minimize cost. That means capital and labor. Now, the question arises now, we talk about cost minimization with varying output levels. So here we bring in, a new term, curve or a new path actually, what we call it the expansion path. Now, what is the expansion path? It's a curve passing through points of tangency between a firm's isocost line and its isoquant. Now, if we go back to the previous diagram, we identify, for example, this diagram 7.3, which is the important one, point A. That is a point of tangency between isocost C1, that is the cheapest output to produce Q1 by using combination K1 and L1. Now you can use different points of tangency like point A, and then you can derive what we call an expansion path. And that is what an expansion path, you must know what is an expansion path. You don't need to do the calculations. But what is important here is that the expansion path is a curve that will then be connected with the points of tangency between the different isocost lines and its isoquants. And then if you have the expansion path in the long run, because we're talking about long run cost, then you can derive from the expansion path to the long run cost curve. And basically there are 3 steps there that you need to follow. So we will come to that steps to derive it from the expansion path to the long run cost curve. What we need to look at in this diagram, because this diagram is important, because what is important from this chapter or from this section is to compare the firms. Why will a firm produce cheaper in the long run than in the short run? Now you will need the expansion path of a firm to be able to do that. So you can see this diagram is quite easy. You've got 3 expansion paths there, which is that blue lines, isocost curves. and then you've got 3 isoquants, and the 3 isoquants indicates different output. Where we have A, isoquant A, that one is 100 units. It's not illustrated on the diagram. The second one is 200 units, that is the output. The third one is 300 units. So that is the point of tangencies A, B, and C, where the isocost curve is tangent to the isoquant for a certain level of output. There are 3 output levels here that is being illustrated: 100 units, 200, and 300. Now, what are the costs to produce each level of output? For 100 units, the cost to produce that is not mentioned there, but it's $1,000. For the second level of output, to produce 200 units, it will cost $2,000. And to produce 300 units, it will cost $3,000. So, the cost increases as you produce more. So you've got 3 points of tangency. And then if you have that 3 points, then by the line coming from the origin, how does the expansion path originate? It moves from the origin. You can see that thick blue line. From the origin through points A, B, and C. And by connecting that 3 points of tangency, you get what we call the expansion path, or the long-run expansion path, actually. Now, what does this long-run expansion path indicates? It illustrates the lowest cost combinations of labor and capital that can be used to produce each level of output. Now, if you look at A, the lowest combination of labor and capital on the vertical axis and labor on the horizontal axis, the lowest cost combination of labor and capital is 25 units of capital and 50 units of labor. The lowest cost combination to produce 200 units is 50 units of capital and 100 units of labor. That is tangency point B. And to produce 300 units, that is tangency point C, you need 75 units of capital and 150 units of labor. So that 3 points illustrate the lowest cost combinations of labor and capital that can be used to produce each level of output in the long run. And remember, in the long run, both inputs are variable. It means that you can change your capital, you can change your labor, or you can substitute capital for labor, or labor for capital, right? So that is very, very important. If you explain this in the semester test or in the exam, I will only need actually the slides explanation that is that is required, because you don't need to explain it in detail. Right, so that is the long-run expansion path. This is how the long-run expansion path is derived, by connecting points of tangency of the isocost curves or line with the isoquant for different levels of output. Now, if you have the long-run expansion path, you can then derive from that. You can see in the lower figure, you can then derive the corresponding long-run total cost curve. And you use that 3 points of tangency, and then you get points on points D, E, and F on the long-run total cost curve. And now you use that information in the top figure. And then if you look at now the diagram in the latter part of this figure, or the lower part, you will see what is being measured on the vertical axis is the cost in dollars or in rands, and then 3,000, 2,000, and 1,000. And on the horizontal axis is the output, which is then that information you get from the top figure. Both, in fact. The cost, you get it from the top figure for different level of output, and then the number of units, 100, 200, and 300. So to produce 100 units, it will cost 1,000. Now that information, that gives you point A corresponds with point D on the long-run total cost curve. So actually you use the firm long-run expansion path to derive the long-run total cost curve by using that 3 points of tangency in this example, and the cost to produce the certain level of output, and then the output levels on the horizontal axis. Point E will correspond with 200 units, and the total cost to produce 200 units will be 2,000. And that will correspond with point B in the top diagram or graph. And then point C will correspond to point F on the long run total cost curve, and that will indicate for 300 units, the total cost to produce 300 units is 3,000. So the long run total cost curve is derived from the long run expansion path. So this is how you get the what we call the LTC, which is upward sloping straight from the origin. Okay, so this is the long run expansion path, and how do you derive the long run total cost curve? Now you can ignore all of this, the practical examples there, but what is very, very critical is this diagram in terms of the semester test, because when we compare long run cost and short run cost, why will firms then, why will long run costs be more flexible? And because of the greater degree of flexibility, long run production is cheaper comparing with short run production. Now this diagram is important in terms of the semester test. Now you will see, the tools that the economists are using is the ISO cost curve, which is the blue line, the straight line. And then we've got the ISO quant, Q1, which indicates, the certain level of output that can be produced if you're on that ISO quant. Now, if the firm produce in the short run, then its cost of production may not be minimized. Why? Because remember, in the short run, capital are fixed. But in the long run, both inputs are variable. So let's assume that the firm wants to produce Q1. That means isoquant Q1. That is the output. So to produce that output, initially the firm will then use L1 and K1. K1 for capital and L1, input for labor to produce Q1. Okay, now the question is, that is the assumption. We start initially from Q1. But what happens now if the firm in the short run, if the firm wants to produce maybe Q2, want to expand production, what can the firm only do? You will see K1 cannot be changed now, because we assume that in the short run, capital is fixed. So if a firm in the short run want to produce Q2, it can only do that by increasing labor, not capital, because capital is fixed. So to move from, to produce Q1 and to move to isoquant Q1, then a firm have then to increase labor by employing labor from L1 to L3, right? Because capital are fixed. So it means that it will cost the firm more, because now you're on a different isoquant. The previous isoquant was AB. Now you're on isoquant EF. Isocost EF. So if you compare isoquant AB, isocost AB and EF, then it means it will cost the firm more to produce Q2 in the short run, because it has to now employ more labor to move from up till P, and to move to point P, you have to employ more labor from L1 to L3. You cannot employ more capital, because we assume that in the short run capital is fixed. Now that is in the short run. Now what happens in the long run? Now you have to compare in the long run. The same output, that means Q2, can be produced cheaper by increasing labor from where? Only from L1 to L2. And capital from K1 to K2, okay? And that is where the isoquant Q2 is now tangent to CD, isocost CD, which is a lower cost than EF. That means to produce Q2 costs less in the long run than to produce Q2 in the short run. Because in the short run, you will be on isocost curve EF, which is further away from the origin. That means higher cost. But if you look at where isoquant Q2 is tangent to isocost curve CD, then it's on a lower isocost curve. That means you only need to employ more labor from L1 to L2 to reach that points of tangency. That means you don't need to employ labor from L1. In the short run, you have to employ labor from L1 to L3 in the short run to produce Q2. In the long run, you only need to increase labor from L1 to L2. So it means that the cost of labor, you need less labor in the long run. Then in the case, if you look on the vertical axis, remember capital is fixed in the short run, so that's why it's a horizontal line. So you will see that the short run expansion path is actually horizontal. It starts from the origin, upward sloping, and then when it reaches that point, then it becomes horizontal until point P, straight if you want to produce Q2 in the short run. Because the Y is horizontal because capital is fixed in the short run. But if you look in the long run, if you look at to produce Q2, you only need to, because both inputs are variable, it means capital is also variable. So you can employ more capital to produce Q2 as well. So then you move from K1 to K2, okay? And to get to that point of tangency. So to summarize basically, in the long run, you can produce Q2 cheaper by increasing labor from L1 to L2 and capital from K1 to K2. If you want to get output level Q2 in the short run, you will have to increase labor from L1 to L3. And then capital remains fixed at K1. And then if you look at the ISO cost, which gives you the lowest possible combination, where you can minimize cost, you will see we are then lying on isocost curve CD, which is lower than isocost EF in the short run. So what this diagram actually illustrates is that long run production is cheaper. It's more flexible than short run production. And this diagram, in terms of the semester test, you have to be able to draw. It looks complicated, but it only consists of what? It consists of 3 isocost lines or curves. It consists of 2 isoquants, which you then draw and get the points of tangency, and then your different units of capital and labor. And please, when you draw diagrams, you label your curves and you label your axis, because you can become confused. So draw your axis, your horizontal, your vertical axis, label your axis, capital, labor, then draw your isocost curves, the 3 AB, then EF, and then later on it will be CD, and then draw your 2 isoquants, get the points of tangency. Now, remember from the previous diagram, that upward sloping curve, that is your long run expansion path. And how do we get that long run expansion path? Is the 2 points of tangency. That is here now. Initially K1, L1, that point, and then K2 and L2. And you use that 2 points of tangency to get the long run expansion path. The short run expansion path, you will see up till where we have L1 and K1, up till that point, that means Q1, it is like a normal, the upward slope, but then it becomes horizontal because capital remains fixed. So the short run expansion path then becomes horizontal because of capital is assumed to be fixed in the short run. So yeah, this is a very, very important diagram, and this illustrates 2 things, that short run production is inflexible because capital is assumed to be fixed, and short run production is more expensive than long run production. So make sure that you are able to draw this diagram. Right, you don't need to know this actually in the long run. We know that we've got the long run average cost curves. We've dealt with that last year as well. And the short run average cost curves. And we got also the long run marginal cost curve. And then, just a relationship. I won't ask you to draw this diagram. It's just a relationship between the LMC and the LAC. And when the firm is producing an output where the long run average cost curve, the LAC is falling, the LMC is less than the LAC. And then on the opposite side, conversely, when LAC is increasing, you can see that, then LMC lies above the LAC. And where the two curves intersect at point A is where the LAC or where the LAC curve achieves its minimum. So the LMC actually intersects the LAC at its minimum point at point A. Now, this we dealt with in the first year as well. And you remember we talk about the average marginal rule, the relationship between average and marginal curves. And this is just illustrating the average marginal rule. So you can just revise this. Right, so in the long run we've got, and you've also dealt with this last year, but I can test you on certain concepts in the semester test. And we're just revising this, and we are again looking at what are the reasons why we get economies of scale and diseconomies of scale. Now, economies of scale and diseconomies of scale is only applicable in the long run. Now, what do we mean by economies of scale? That is the first part of the slide. As output increases, what happens with the firm's ATC, or the long run average total cost curve? It declines up till a certain point. And then you get diseconomies of scale, then the LAC is increasing. Then it's not any more effective for the firm to produce further than that point, or the scale of the operation becomes too big. Now, why will there be diseconomies or economies of scale? Now, you need to know what is economies of scale. As output increases, the firm's average cost of production, that output is likely to decline at least to a point. And we're talking about the long run average cost of production to distinguish from the SAC, the short run average cost of production. Now, there are three reasons mentioned in the slide why will we have economies of scale. And every firm, especially your large conglomerates and your large firms, wants to experience economies of scale because that will bring in lower average cost per unit, which means the firms can charge lower prices, and then the potential for greater profits are there. Now, normally firms that experience economies of scale are firms that operate on a large scale. And then why can firms then, if the firm operates on a large scale, what can workers then do? And this can then bring in economies of scale, workers that can specialize in the activities at which they are most productive. And you can find it if you look at, a motor car manufacturer. If you look at the assembly plant of a motor car manufacturer, or say, Coca-Cola, which produces bottles of Coca-Cola, of cans, workers specialize only in a certain task. So you have division of labor, and you have specialization. It means that workers become more productive because they only specialize in a certain task. And if workers can specialize in a certain task, they become more productive. More productivity means lower cost per unit. And, that can only happen, on a large scale. And why then economies of scale? Because workers are able then to specialize in the activities in which they are most productive. The second reason, if you produce on a large scale, you've got more flexibility. So it means that you can have various combination of inputs to produce the firm output. So you can look at, what the combination will minimize cost of labor and capital. And then the production manager can then organize the production process in line with that. Because in the end, the aim is to minimize cost. So that can only be done on a large scale. Where the firm then can, try to experiment and looking at what combination of labor and capital can be there to minimize cost. Then the third reason is that, remember to produce, a firm needs raw materials. So a firm needs raw materials or a firm needs labor. Now, especially raw materials that you need to produce, a bigger firm then will buy in bulk. So it means that they can, get the inputs or the raw materials at lower cost because they buy it in larger quantities. They can negotiate better prices. That means lower input cost. Okay, so they are lower cost in terms of inputs, and that can also lead to a lower average cost per unit, which will lead to economies of scale. So these are the three reasons why, economies of scale can be present in the long run. But on the other side, at a certain point, when your firm becomes too big, it's all about scale that we're talking about, the size of the plant. Now, if the size of the plant becomes too big, then what might happen is that the LAC, the average cost of production, will begin to increase as you increase your output. Now, no firm wants to encounter that because it means that the cost per unit to produce every unit is now increasing. So what can be the reasons for diseconomies of scale? They mentioned three reasons there. So especially in the short run, at least in the short run, factory space and machinery may make it more difficult to do the jobs effectively. No, that is not in the long run, right? So in the short run, there might be a problem because you cannot, build more buildings in the short run. It's difficult to expand your factory in the short run. You cannot install new machinery in the short run. And then that might impact on the productivity of workers. And if the productivity is high or low, the cost of production, the cost will increase. The LAC will increase. That means we will experience diseconomies of scale. And then sometimes if you have a large firm, it becomes too big. Sometimes big is a problem. And then it's difficult to organize from the production point of view. Coordination will become a problem, and then inefficiency will come will be on the table. And then if you have inefficiency, it means that productivity declines. And if productivity declines, it means that the cost of production increase, and that leads to diseconomies of scale. Then also we mentioned in point 3, when we looked at the economies of scale, buying in bulk might have its advantages, but at some point, if you buy in bulk, then there's limited supply. Sometimes the input that you need, the raw material or the labor, maybe skilled labor, there's limited supply of skilled labor, or there's limited supply of that raw material or natural resource maybe in the country, and that will push up because of the limited demand and supply, because supply is limited and demand is exceeding supply. It will push up the price of that input, the price of labor. To get that skilled labor, you have to pay higher wages, or the price of that raw material will increase because of the scarcity of that raw material. And that will push up the cost of production, which will lead to a higher average cost of production. The long run average cost will increase, and that means you will experience diseconomies of scale. Now, if a firm experiences diseconomies of scale, then they need to look at maybe downscaling the size of operation, because now the size of operation are too big. It becomes too complex, too difficult to organize, and for supervisors as well. And then maybe they need to downscale. So just to summarize it, you need to understand the difference between economies of scale and diseconomies of scale, and then also what are the 3 reasons for this. So this is just to summarize it. Economies of scale is a situation in which output can be doubled for less than doubling of cost. So it means that if you double your input maybe by 10%, then your output will increase maybe by 20%. Then you will have economies of scale. Diseconomies of scale, where if, say for example, you double your input increases by 10%, then your output will only increase by 5%. So that means you will experience diseconomies of scale. Then just to not to confuse you, a firm in fact can experience economies of scale, increasing returns to scale. Or actually diseconomies of scale and as well as increasing returns to scale. So don't get confused with that two terms. Because when we talk about increasing returns to scale, it means that output more than doubles. But we talk about proportionally, yeah. When we talk about returns to scale, we talk about proportionally changes in input versus output. So just revise that as well. Okay, so yeah, you don't need to know, economies of scale are often measured. How is it measured, in fact, and you don't need to know that equations. And this diagram, actually, you don't need to look at it again. You can just revise it. But we've done this diagram last year. But I won't test it now again in the second year. It's just to indicate to you the relationship between short-run and long-run cost curves. So you have, the LAC curve. That blue, the thick blue line is the LAC curve, which is enveloping. It's like an envelope. It is the envelope of the short-run average cost curve, SAC1, SAC2, and SAC3. Now, if you can remember from last year, I asked you to draw the LAC curve. Now, the reason I asked you to draw the LAC curve, I didn't ask you to draw the the short-run average cost curve, the short-run marginal cost curve, was actually just to indicate, if you look at the LAC curve, the first part of the LAC curve is declining. Now, the reason why it's declining, the thick blue line, is because of when we produce output Q1 to Q2, the firm is experiencing economies of scale. And then after producing Q2, further on, you will see the LAC curve is increasing. It's rising. That means then the firm will produce at the diseconomies of scale. So for a firm, it will be best only to produce up till output Q2 and not to go further. Because to go further than Q2, a firm will then experience diseconomies of scale. And remember, the reason for the SAC curves, the SAC1, SAC2, and SAC3 is just to indicate different plant sizes. You will see with economies of scale and diseconomies of scale, the minimum points of the SAC curves do not lie on the long-run average cost curve. And that is another important point there. So actually the aim of this diagram is just to indicate to you that the LAC curve is derived actually from the SAC curves, which indicate different plant sizes. And the LAC curve is like an envelope. It's enveloping the different short-run average cost curves. And this is what actually is happening. And then you get your SMC1 and your SAC1. Now, you remember that is also from first year. And then you get your LMC curve as well, the red line. But what is important from this is that, the LAC curve, you derive the long-run average cost curve from the short-run average cost curves. And the long-run average cost curve is like an envelope of the SAC curves. But we've done this diagram last year, so I won't ask you again to describe it. Then some new things. Remember, previously we only dealt with outputs, one product that is being produced. But what about production with two outputs? In this case, the firm is producing tractors as well as cars. The number of tractors, is measured on the vertical axis, and the number of cars on the horizontal axis. Now, what is this curve that you see here? It's like a production possibility curve, but we call it production transformation curve. It has the same shape. It's concave downwards. Remember, the production possibility frontier is concave downwards. It bulges away from the origin, indicating increasing opportunity cost. Now you will see this transformation curves, the product transformation curves Q1 and Q2 are also bowed outwards or concave. And the reason for that is because of economies of scope. Now that is a new term. So let's just look at what is a production transformation curve. It shows the various combinations of the two different outputs. Now what we mean by outputs, that is tractors and cars that can be produced with a given set of inputs. So when we talk about Q1 and Q2, that shows the various combinations of the two different outputs, that can produce a given set, that can be produced with a given set of inputs. So this is what we call a product transformation curve. And you will see there are two in this diagram, and the shape of this curve is concave, is bowed outwards. And I won't ask you to draw this curve, but what is important is the reason it's bowed outward is because of what we call economies of scope. And this is new terms. So I can ask you in the semester test maybe to distinguish between economies of scale, diseconomies of scale, and economies of scope, and diseconomies of scope. And this is what we have illustrated by using what we call a product transformation curve. Now, we talk about two outputs, two products that is being produced. Now, what is then economies of scope? Is a situation in which there are one single firm produce both products. So there's a joint output of a single firm. And why will we have economies of scope? So it means that the joint output of a single firm is greater than the output that could be achieved by two separate firms producing a single product. So it means that if one firm produces tractors and cars, and their joint output will be greater than if two firms produce only cars and another firm produce tractors. Now, if that happens, the joint output of the single firm will be greater, and then we say that firm experiences economies of scope, which is illustrated by a bowed outward, concave downwards transformation curve. Now, the opposite is also true. When a firm experiences diseconomies of scope, then it means that the joint output of a single firm will be less that could be achieved by two separate firms producing a single product. So in that case, if one firm produces tractors and cars, both products, their joint output will then be less than a separate two firms producing, one firm producing tractors and the other firm producing cars. Then the firm, it will not be in the interest of that firm to produce both cars and tractors. It will be better for single firms to produce a single product. Then if that happens, that firm will then experience diseconomies of scope. So what is important in terms of the test is the concepts here. I won't ask you to draw the product transformation curve because that is quite easy, but you need to know the difference between what we've learned last year, economies of scale, diseconomies of scale, returns to scale, increasing returns to scale, constant returns to scale, decreasing returns to scale, and then the new terms, economies of scope, diseconomies of scope. I will ask you to distinguish between that concepts in the semester test. You don't need to, when we study further in economics, we will look at the degree of economies of scope, in terms of, because if a firm produces both products, it means that they will save on the cost of production. Now, that you can measure that percentage that is saved by using this, formula that we call SC, the degree of economies of scope. Actually, it's a percentage of cost saving resulting when two or more products are produced jointly rather than individually. But I won't ask you to calculate SC. Okay, so you can maybe ignore that, and then we will only go up till 7.5. The learning curve is not required for this module, so you can ignore 7.6. So just to summarize, we have looked at cost of production cost. Firstly, we looked at work from last year, the short run production cost. I just revised that. And then we focus on the long run. and you know, the long run cost of production, and we look at why is long run cost or long run production more flexible than short run production, and we also look at, you know, deriving the long run expansion path, which shows the cost combinations of inputs, labor and capital, that will minimize the cost of production. Then we move to the deriving the long run expansion path by using that points of tangency between the isocost curve, which is the new curve that we brought in, and the isocost line or the isoquant line, and using that points of tangency to get the long run expansion path, and then from the long run expansion path we derive the long run average cost curve, and then we use the long run expansion path to indicate the inflexibility of short run production. That diagram is very important, and also to indicate why production in the long run is more flexible but also cheaper. Okay, and then we went to economies of scale and diseconomies of scale, and then we looked at, you know, the relationship between short run and long run cost, and then using, you know, the LSC, and then we looked at production with two outputs where new terminology came in and a new curve, the production transformation curve, and then we looked at economies of scope and diseconomies of scope. So up till there, that is important in terms of the semester test and also in terms of the exam. 7.6, like I said, is not required in terms of the learning curve. So yeah, that then concludes chapter 7, the cost of production. Thank you.